Figure 1 shows a sector OPQ of a circle with center O. The radius of the circle is 18 centimeters and the angle POQ is 2 pi out of 3 radians. Find the length of the arc PQ, giving your answer as a multiple of pi. So we know that the length of an arc equals r times theta is the radius, theta is the angle, so that would be 18 multiplied by 2 pi out of 3 and times 6, that is 12 pi. So I get that's the length of the arc. Then figure 2 shows the sector OPQ and the kite OPTQ, and PT is the tangent to the circle at P and QT is the tangent at Q, such that angle PTQ equals alpha radians. Find alpha in terms of pi. So now the angles are pi out of 2, pi out of 2, and alpha would be 2 pi. The sum of the angles equals 2 pi. It's a quadrilateral kite, so minus pi out of 2 plus pi out of 2 plus 2 pi out of 3, 2 pi minus pi plus 2 pi out of 3, and that is 2 pi minus 3 plus 2, 5 pi out of 3, 6 minus 5 is pi out of 3. So once we get that, we can say that alpha equals pi out of 3, that's in terms of pi. And the next part is calculate the three significant figures. The area of the region shaded in figure 2, which is bounded by the arc PQ and the tangents PQ, PT and QT. So what we can do is, because it's a kite, I'll draw the diagonals, divide it into 4 triangles or 2 large triangles, OPQ, find the area of OPQ, find the area of PTQ, add them up, area of the kite, subtract the area of the sector from it. So OP and TO, oh no, not OP, sorry, PQ and OT. PQ and OT are diagonals intersect at right angles. So we got that sorted. So then triangles are isosceles, and I say that as X. OX is the perpendicular bisector, so triangle OPQ and triangle PTQ are isosceles. OX and TX bisect the angles. I'm only writing that much, and then the angles would be that's 2 pi out of 3, so angle XOQ would be pi out of 3, pi out of 3, and then angle XTQ, we already know alpha is pi out of 3, so this would be pi out of 6 and pi out of 6. Okay, so that bit is important. Then I can use, if I say sine pi out of 3, that in triangle OXQ, I can say sine pi out of 3 equals OX or XQ divided by 18. So sine pi out of 3 is root 3 out of 2. So I can say root 3 out of 2 is XQ out of 18. So XQ is 9 root 3. So I get 9 root 3. Px would also be 9 root 3. And therefore PQ would be 18 root 3. Now we got to find the height. So to find the height, I can say tan of pi out of 3 equals 9 root 3 divided by OX, and tan pi out of 3 is root 3. So I can say root 3 equals 9 root 3 divided by OX. So OX is 9. So this is 9. And similarly for the other triangle TXQ. So in, should I use maybe a darker one? In triangle TXQ, what do we get? We can do the same thing to find TX. So we say tan pi out of 6 would equal 9 root 3 divided by dx. Now tan pi out of 6 is root 3 out of 3. That is 9 root 3 divided by dx. So dx is 3 times 9, that is 27. So that is 27. Okay, so we know the height and we know the base. So we have to find area of triangle OPQ equals half times 9 times 18 root 3. So then I'd get 9, and that is 81 root 3. Okay, that's one. Then area of triangle PTQ equals, I would get half times 18 root 3, base is the same, multiplied by the height, which we got as 27. So then 9. So that would be 27 times 9. 243 root 3. So that is the area. Now we got to add the areas up. So area of the kite OPTQ, that equals 243 plus 81 root 3, that is 324 root 3. Just checking if I get everything right. Yes, I think. So area of the kite OPTQ equals 324 root 3. So now I have to find the area of the sector. area of sector what's the sector? OPQ, and that would equal half times 18 times 18 times 2 pi out of 3. 2 times 9 is 18 and 3 times 6 is 18. So I would get 50 is 108 pi. Hope I got it right. Yes, it's 108 pi. So once I got all the required areas, got to subtract them. Area of the shaded region. Final bit. Area of shaded region would equal 324 root 3 minus 108 pi, and that equals 1.73 times 324 . Taking me a while to do it. 1 times, I think you've already got the answer now, I'm struggling. It's 560, and then 108 pi is 339. And that is 221. That's what I get. Now, I don't know, I may have ignored the decimal places, so let me get it right, because it's correct to 3 significant figures. So I must have got some error somewhere. So it's 324 or not, I don't know, multiplied by so it's 560.52 minus 339.12. I get 221.4. So, but we need correct to 3 significant figures. So that is approximately 221 centimeters square. Okay, so that is the area of the shaded region.